Today we will study a serial adder. In serial adder, in each serial adder, only one full adder is required, is used to add any number of bits. To add the AND bits, we require minimum AND clock pulses. Okay, so it is the slowest adder. I will explain you by the diagram. There are two shift registers A and B. If we want to add a 4 bits numbers, okay, so two 4 bits numbers are stored at A and B, and there is one full adder which is used for a serial adder. It will do an addition process. Means if we want to add A0 and B0, so these will be add in a full adder AB and gives a sum. If there is any carry out, means this will store in a flip flop, because flip flop is used for the storage. And there is clock pulse also used, which is given to the flip flop for the next bit. Also, if we want to add A1 B1, then it will as an input for the full adder A1 B1, and the previous carry pulse is given by the Cin of the A0 and B0. It will give an output, and if there is any carry out, again it will be stored. The second clock, so if we given a clock pulses, it will do a adding. Serial adder means it's adding a serially. Okay, so this is a serial adder. But the disadvantage of serial adder is that it is used clock pulses. Okay, minimum number of clock pulses. So it is slowly processed. In addition, we have to do a one bit, then second bit, then third bit, then fourth bit. So this drawback is overcome by the parallel adder. How it is? If we add a 4-bit parallel binary adder, this is full adder. Okay, here also we are using a separate full adders for adding a bits, but in serial adder we have only a one full adder and it is adding a one number, then after that, so it's causing a slow problem. Okay, so by removing this, we are making a, if we want to add a 4-bit, so there will be 4 full adders having a inputs. Okay, and we know that full adder having a 3 inputs, A0, B0, Cin. There is some not, which is, this is AND bits, addend bits, AND addends. Okay, so these were the, and these are the sum. Now in a full adder, if we are adding a A0 B0, there will be a carry is generated. If carry is generated, then that output is given to the full adder. If there is not any carry, so it will not work on it. It will not go to the next process. So this is a main problem in a parallel adder. As there are some points, 4-bit parallel binary adder required 4 flip-flop. In parallel adder, to add each bit, separate adder circuit is used. If you want to do a addition in parallel, so we are using a separate bit for the, and so means using a separate adder for the each bit. If we want to do an AND bit addition, we require n-1 flip-flops. Okay, in parallel adder, each full adder will provide a delay. See here, because of that it's creating a delay. Okay, if the carry is not generated, the process will not work it, and it causing a delay in the circuit. So it is also known as ripple carry adder. In parallel adder, each full adder will provide a delay. Okay, it is also known as the ripple carry adder. So the disadvantage of that carry propagation delay will present from input to output. There is a carry propagation delay in Farreller adder. So that's all.